This particular problem, we are going to look at a resistor of 500 ohms is attached to an uncharged capacitor with a capacitance of 1.5 microfarads and a battery with a voltage of 10 volts. They are in series. So this is an RC circuit, and some of the equations that I'm going to use can be found in your lecture notes. So if you're not sure where some of these things are coming from, please refer to those. So for the following questions, the first thing that we are going to look at is what is the initial current? And let's call that I naught. All right, so initially the capacitor is uncharged. So it's not going to use any potential difference to cross the capacitor, right? There's none of the potential, none of that 10 volts is being used to cross the capacitor, so that's a 0 volt difference. And that means that the initial current is really going to be set by the resistor, and that is going to use up everything that the battery is supplying, so that's going to be our 10 volts. And in order to figure out what that current is, we can just apply Ohm's law, right? V equals IR. And so our initial current is going to be 10 volts divided by our resistance of 500 ohms, and that is going to yield 2/100ths of an amp. Now, the next question is, what is the time constant? What is the time constant of this circuit? Well, the time constant, we use tau as the symbol for time constant, and that is going to be R times C. We're going to see that there's other time constants that show up in different types of circuits, but for an RC circuit, it's the product of the resistance and the capacitance. And so that's going to be 500 ohms times 1.5 microfarads, or 1.5 times 10 to the minus 6 farads. And that is going to yield a very small time constant, 7.5 times 10 to the minus 4 seconds. And it really is a unit of time. And you can refer to the notes to see the proof of that. And so next we're going to figure out what the current is. The current after two time constants. So RC circuits change their behavior with time. An uncharged RC circuit will start off with a larger amount of current, and then that current decays with time. And the reason for that, again, you can refer to the notes. This is actually an exponential decay. And essentially this is happening because the capacitor begins to accumulate charge on the two plates of the capacitor. That requires some potential in order to cross over that in the circuit, and eventually the capacitor will require all of the potential that's being supplied by the battery, and at that point the current is no longer running. So that happens over time. You can see it's an exponential process, and where this formula comes from is also contained in the lecture notes. But to get to this particular numerical solution, we can just plug in our original value for the original current times little e to the minus t over RC And for 2 time constants, well, that is going to be 0.02 amps times e to the minus 2 times RC. So we get a little cancellation happening up in the exponential. And when we evaluate that exponential out, multiply by our current, we get 0.0027 amps. And so this is our current at t equals 2 tau. The final thing that we're going to look at is the potential difference. So the potential difference on the capacitor after 3 time constants. All right, so the potential that is required to cross our capacitor is our original voltage being supplied by the battery times another exponential term, or the product of a decaying exponential. And so this is going to be 10 volts times 1 minus e to the negative 3 tau over tau, where tau is RC, our time constant. Those cross out, and so we have a 10 volts 1 minus e to the minus 3, and this is equal to 9.5 volts. And so here you can see that as time increases, basically 3 steps of our relatively small time constant, that capacitor is using 9.5 of the available 10 volts in our circuit. The resistor would be using the other half a volt in this case. So if you have any other questions about this, please refer to the notes, and all these equations are shown there along with their derivations. You can also refer to your text.